All right, chapter 6 is over similarity. Section 6.1 is going to be a review. You've done this in algebra except for geometric mean. Ratios, proportions, and geometric mean. Our learning targets for 6.1. Be able to set up and simplify ratios. Be able to use ratios for different applications. Be able to set up and solve proportions. Be able to find a geometric mean of two numbers. Simplify the ratio. Okay, to simplify this ratio, you're going to put the first number on top, 6 meters on top, 64 meters on top, 6 meters on the bottom. The units cancel, the meters go away, and then we have to reduce this fraction. Okay, so what goes into both 6 and 64?
2.
Right, we can make this equal to 32 over 3. So I would simplify that to 32 over 3.
What's the definition?
Because they do, George.
B, what would B simplify to?
1/4.
No.
Darn it.
Is it just 1/4?
Or 1 foot 4 inches?
Yeah, 1 foot over 4 inches because the units don't cancel. So it's 1 foot to 4 inches. Oh, no, that's not right.
Oh man.
Oh,
I got it.
We have to convert to the same, we've got to get them to the correct same number of units, right? So how many inches is 5 feet?
3 inches.
Right, 60. So it's 5 times 12 is 60. Because there's 12 inches in a foot, so it's 60 inches over 20 inches. 20 inches. So that's, yeah, what's that going to simplify to? 3 over 1. Good. All right. So there's a colon in between. The first number goes on top. And then this is the way I want you to express ratios as a fraction.
What about
All right. Any questions?
Yes, I got a question.
What's your question, Justin?
Why do the thing cancel out?
Why what?
Do they cancel out?
What cancel?
Why do you take them away?
Because it's you think of it just like a number. If this were a 4 and that were a 4, you'd cancel it. Okay? Meters divided by meters, the meters go away. All right.
Sorry, I don't trust people.
All right. You guys go ahead and simplify the bottom two there.
Isn't that just like the same thing?
Thank you, Kaylee.
It's already doing it. 8 over 1,
Wait, was that right?
The first one is 8. Yeah, it's 24 yards divided by 3 yards is 8 over 1. Okay, then we've got the centimeters there. Okay, I think it'd probably be easier to convert to centimeters. You're going to end up with whether you convert the meters to centimeters or the centimeters to meters, you'll still end up with the same ratio. Let's convert how many centimeters in a meter?
100.
So what does this 6 meters become in terms of 600? Right. So it's 150 centimeters over 600 centimeters, which is going to be 1 over 4. Right? Okay.
Hey, what'd you guys do for number?
1 over 4. 1 to 4. Okay. Next example. You're planning to paint a mural on a rectangular wall. You know that the perimeter of the wall is 484. the ratio of its length to width is 9 to 2. Find the area of the wall. Anybody know how we would do this?
Not, wait, divided by 9. You do 484 divided by 4. No, you do 400, you set it up like 404 over 1 times 9 over 2.
Anybody else? Okay, on these where they give you the ratios of the sides, you just make them an X, okay? So that's going to be, so if the ratio, you look at it like this. If we drew a rectangle, we know the ratio of the sides is 9 to 2. Then we could call this 9x and this 2x.
Oh.
So we would say 9x times 2x equals 484,
Wait, was that?
because we're finding the area.
No, you're finding perimeter, right?
Oh, yeah, we went perimeter, don't they? Okay, so, yeah, I take that back. So we have, for perimeter would be 9x plus 2x plus 9x plus 2x
Oh, yeah.
equals 484. So that's going to be 18, 20, 22x.
Can you just square it or no?
No, we don't square it because we're not multiplying.
Oh,
22x equals 484. All right, so 22 goes into 484. Yeah, it is 22. It goes in there 22 times. So x is 22. All right, so then to find the area of the wall, we would plug in x. So this becomes 9 times 22 on this side, and this is 2 times 22. So that's going to be, what is, so it's going to be 44 times, what is 9 times 22?
198.
198.
You're so good. I know.
All right, so 44 times 198
Alright.
gives me what? 8,712.
Yeah.
8,712, and that would be feet squared. All right, so again, let me recap on this. Anytime, there'll be other variations of problems like this. Anytime they give you ratios of sides on a shape, and you just add an x to it. Make the side 9x, 2x, right? Whatever ratios they give. Like on a triangle, if they say the side lengths are 3 to 5 to 7, then you're going to call one side 3x, the other side 5x, the other side 7x.
What's the thingy majigger?
We're going to build a wall.
What's the...
8,000. That's like my trunks.
Are you...
That's the one with the trunks.
All right, everybody got it? Okay, use extended ratios. The measures of the angles in CDE are extended ratio of 1 to 2 to 3. Find the measures of the angles. Okay, just what I was talking about. You can do the same thing not only with side length, you can do the same thing to angles. We've got these three ratios in here. We made them times x. How am I going to find the angle? What do I need to do? Not going to square them. Jayden?
I got it.
All triangles equal 180.
Right, so they do.
So would you put 3x plus 2x plus x equals 180?
Yes, you would. That's correct. 3x plus 2x plus 1x equals 180. So then we have 6x equals 180. X equals 30.
So, angle 1 would be 30, angle 2 would be 60, angle 3 would be 90.
Yeah, so we have to plug back in. So, yeah, this would be 30, Then 2 times 30 is 60, and 3 times 30 is 90. So those would be your angles. Everybody have it? All right. Okay, there's some more examples there. The perimeter of a room is 48 feet, and the ratio of its length and width is 7 and 5. Find the length and width of the room. All right, how would we set this one up? See if you can do this one.
Oh wait, was it like 48 equals 7x and 5x?
7x plus 5x
The X.
equals 40.
Yes.
Yes, you would do 48. You would do 48 equals 7x plus 5x plus what?
Is it equals
That's just 2 of the walls. What are the other 2 walls going to be?
7x and 5x.
7x plus 5x. And then solve it from there.
There's 3 sides.
There's 3 sides, and you just add. You just determine which one. If it's the longer 2 walls, you'd use 7x twice. If it's the shorter 2 of the walls are shorter, then use the 5x. Right. Okay. Then the other example is very similar to the. We're not going to do it. This about the same as the one we just did it with triangles. So let's do. Okay, now we do proportions. How do we solve proportions? What do I need to do to these ratios? Yeah, cross multiply. So let's practice cross multiplying. So this becomes 5 times 16 equals 10 times x. All right, so it's going to be 50, 80 equals 10x. So x equals 8.
I like that one.
Yeah?
So on the top before these examples, it shows a definition. Is it proportion? Is it an equation that states 2 ratios are equal, or is it just proportion?
Yeah, should be proportion.
Okay.
Yeah, the proportion. That definition up at the top, it was for some reason it's not in the slides. That definition is a proportion, says 2 ratios equal. Justin.
Did you finish number 3 and 4? We skipped them.
No, they weren't on the slides.
Those I did I kind of briefly did 3, I think, and then we did number 4. It's the same as this one.
Oh, it is the same one.
Yeah, except you're using 1, 3, and 5 instead of 1, 3, and 2.
Oh.
Okay.
And so number 3. Am I doing? Did I do that right?
Hi, Mateo. Where's he at?
With 4x, yeah, you'd find x, and then you'd plug in. You'd get x is equal to 2, and then you would plug in. The length would be 7 times 2, would be 14, and the width would be 5 times 2, 10.
Oh, okay.
Okay. All right. B. Now be careful when we cross multiply. Make sure you use distributive property. So we've got 1 times 3y is equal to 2 times the parentheses y plus 1. Don't just put 2 times y plus 1, because the 1 is, we have to distribute this 2 to the 1, not just to the y. So we simplify, we're going to get 3y equals 2y plus 1, so y equals 1, so that's our answer, y equals 1.
It's 2 times 1.
Oh, I missed it. What I talked about. Yeah. Y is 2. Y equals 2.
There you go.
Y equals 6.
Questions?
How'd you get the Y by
So basically cross multiplying is like
How did I what?
How'd you get the Y by How'd you get Y equals 2?
I subtracted
subtracted 2y.
2y, subtract 2y from both sides.
Jeez, man.
Okay.
So basically all cross multiplying is just distributing the both.
Be careful, guys. You gotta be
You
careful
said
on
the
this
top
problem.
definition is proportion.
Proportion, yeah.
Hey, you really got
All right, any other questions?
I'm tired.
There's the definition.
I think I gained too much inertia.
Oh, vocabulary alert.
Yeah, I definitely got too much inertia once today.
Are these examples in your notes?
Yeah.
Yes. You want us to do them by ourselves? Just
Hold up, but how does
yeah.
16 equal?
Go ahead and do them. Do them.
Haven't we really already done proportions?
no, not this year.
Well, finding the slope we did.
No.
Yeah, we did.
Hot chocolate. Me too. Aw.
Or you said you guys are low.
You guys are really late. I did that like 5 minutes ago. I remember. She said bye. Okay.
Teachers and students part of this election. At this time, we need all pep rally MCs, the dance team, the pep session band members, the varsity cheerleaders, the comedy sports improv members, and the senior football players, all to report to the vanity gym. Thank you.
Senior.
I'm pretty sure I just broke
Oh, are they gonna cut their jeans again?
Ow.
All right, let's go. Keep working. Let's solve these two. Make sure you can do these correctly.
I just kicked the desk.
Ding. Who?
You done? Sign your pass here. I'll sign your pass.
Bye, have a good day.
Well then.
Who's still working?
I'm not working.
All right, so the first answer is 16/5.
Yes.
The second one is 12.
Yes.
Number 7 is 6. Let me do number 7 on the board. I want to make sure you can do
I got it.
I can do it.
do one like that. Somebody want to do it on the board?
I do.
I got it.
Okay, Max, go ahead. Come on up.
Do I have to explain?
Yeah,
Alright.
No, I don't want to.
you're the teacher.
Let's go, Pepe. Yes.
Here, here's a piece of chalk.
Let's go.
He's white.
Thank you.
Max.
Alright, here we go.
Butterfingers.
I bet you're gonna get this wrong.
Oh, I got it.
Too big. You're not
What is
gonna.
that? I thought it looked like
Here's an example of when you can apply proportions in a real world problem. As part of an environmental study, you need to estimate the number of trees in a 150-acre area. You count 270 trees in a 200-acre area. You notice the trees seem to be evenly distributed. Estimate the number of trees. How could we set this up? Any ideas?
You need to estimate the number of trees.
You multiply 270 by. Oh, no, just kidding.
All right, I'll give you a clue. You set up a proportion,
So
Jayden.
Oh, I got it.
So would you have to divide 150 by 2, right?
No.
And then
Would you set up both by 2?
I know what you do.
Justin, what would you do?
multiply it by.
You.
No, you don't.
If I had to guess, You
No, don't guess.
Isn't
No.
it
Nick,
You divide 270 by 2 to get the proportion for 1 acre. And the amount of trees in 1 acre, then you multiply 150 by that number to get.
No.
Wait, no. Okay, so
Yeah, you
know
do
so you
it.
take 270 times.
that might work, but set up a proportion.
Right.
Oh, I got it. Okay. Okay.
You take that number,
200 over
subtract it
2.
by 150.
200.
I was planning to do that.
270
I
over
got
2.
But
Here's what you would do. You would take there are 270 trees and
2.
for every 2 acres?
2 acres, right?
Yeah, that's what I said.
And
So
would
then we
be
set that
equal to
the
150 over X.
then then we would have X trees in 150 acres.
Wait, but wouldn't you want to cancel out the I guess variables, I guess technically, like trees and acres?
Yeah, you don't. I just added that so you made sure you knew it. But you could just write. Yeah, I would not require that. You could just write this as. Let me clear this out. You could write this as 270 over 2 equals 150. I mean, not 150 equals X. The number of trees X over 150. Okay. So that's saying there's 270 trees per 2 acres. How many trees would there be per 150? It's the same. It's going to have the same ratio,
I
right?
understand.
To make that the same ratio as this. So then to solve, we cross multiply. So we have 2x equals 150 times 270.
Which is 40,000.
I need your help.
40,500.
Yeah. That's
2x equals 40,500.
Yep.
So x equals 20,250, right?
Yep, that's correct.
20,250 trees. Anybody know how many? They recently did a model of this. They actually they used computer program, and they identified different areas of densities of trees, and they used this to estimate how many trees are on the planet Earth. Does anybody have an idea what that number was?
12 trillion.
Oh, I got
Is there more trees than humans? Here's the hint.
Yes, there are more trees than humans.
Okay, so I'm gonna go with
17.
Max, what do you think?
I'm going with 450 billion.
17
Jaden.
billion.
I'm gonna go with 29 trillion.
All right,
No.
Justin.
17 billion.
13 trillion.
Wait, I meant
Okay,
44. Like,
the number they got was 3 trillion.
I was
3 trillion trees. They said it used to be before man, before we started cutting down all the trees, so like 1600s, 1500s, there were like twice that many. So man has cut down, has halved the number of trees on the earth from his, lumbering and that type of thing.
But first, let me take a selfie.
What are you doing?
Geometric mean. Okay, geometric mean of two positive numbers, A and B, is a positive number such that satisfies A over X is equal to X over B. Okay? The reason why they call it geometric mean, because when you have a proportion, these numbers, the A and the B, are the extremes, and the X is the means. But a way, rather than remember it as this fraction, the easier way to remember geometric mean is if I have the two numbers, you're going to multiply them and take the square root.
Yeah, that's it. Exactly.
That's it. So the geometric mean here is X equals the square root of 24 times 48.
Wait, wouldn't you divide them by 2 though? To find
No.
mean?
No, you're thinking arithmetic mean. That's average. Geometric mean, you multiply, take the square root. Arithmetic mean, you add and divide by 2. So it's different operations.
That is very.
Yeah.
What's that dot in the middle?
Times
Okay.
multiplication.
Oh.
First I thought it was a decimal
What's my
point.
name?
Oh, the answer is 152.
Did you take the square root?
Oh, 33.9.
So what was the first number? 4,000 something?
1,152.
4,152. So and what's the square root of that?
33.9.
33.9. Did you round to the nearest hundredth?
No.
What's the round to the nearest hundredth? 9.4.
Oh, wait, you take the square root.
No, you multiply them first, and then you take the square root.
Yeah.
Why is there
The dot means multiply.
Multiply.
I know, but like.
And the bottom one, that's a decimal.
All right, any questions?
Wait, why are I
Should be good.
Say my name, say my name.
Come on, that one.
All right.
Not gonna work.
Okay, they did it differently. They simplified the radical. Everybody understand what happened when they simplified the radical?
Yes, I do see that.
You can write. You might want to write this down in your notes because if I ask you to simplify the radical, you need to do it.
Oh, you can't just take the square root?
Yeah.
No, I think we just.
I think we should do it our way. That's
Yeah, can we do it
our
our
way
way,
is like.
please?
It makes more sense.
Yeah, it's
Yeah, because our way it's more precise. That's like.
It makes more
No, this
sense.
is actually the exact answer. Ours is rounded. Yeah, you need to be able to do the radical. So so what they did here, you've got 24 times 48. They factored 48 into 24 times 2. You have 224, so you bring that outside the radical as 1, and it's 24 radical 2. Bryce.
Would you accept both answers?
We'll have to read the instructions. Let's see what the instructions are. When you do the homework, if they give the answer in radical forms, then that's how you should try to do it in radical.
Okay.
All right?
So we just find out when you do the homework, or
Yeah, when you do the homework.
Right now?
no?
Whoa.
Okay, there's the other answer.
Oh, so they didn't do it.
They still do the same.
Okay, it's not necessary to do all of these. Let's do.
I finished them all.
10.
You did finish them already?
Yeah.
Okay, let's do number 9, and let's do it as. I know you can do the calculator way. Let's do it as radical, leaving it in radical form. So 12 and 27. I'll do it on the board. You guys do it in your notes, and then I'll do it on the board.
3, 6, 9. I got it. Easy peasy lemon.
Remember, when you're simplifying a radical, you're looking for perfect squares, or you're looking for a number times the same number, which is a perfect square. That's what you want to look for when you simplify a radical.
I know what it is.
So it's 12 times 9.
It's 18. It's 18.
But go ahead and factor 12 as well.
Oh. It's 18.
4 and 3.
No. 3, and no. 3, 2, and 2.
Let's look at it, okay? So it'd be the square root. Let's think, is there any factors of 12 that are perfect squares?
3. No.
4. 4 times 3 is 12. 4 is a perfect square. We'll come back to it. What about 27? Are there any factors of 27 that are perfect? 9. 9 times 3. All right? So this is a good example because it uses two reasons to bring something out. You can bring the 4 out as a 2 because it's a perfect square, so it comes out of the radical as a 2. You bring the 9 out as a 3, so it's 2 times 3. Then you have 2 3s, right?
Yeah, 3.
If you have 2 of the same number, you bring that out as 1, so it's 3. So then there's no radical left in our answer. It's just 2 times 3 is 6 times 3, it would be 18. 18 is the geometric mean.
The first way, the one way though, we got the same answer. So stupid.
Yeah, because there was no decimal. If there's a decimal, then it's not, it wouldn't be precise to do a decimal when you can do it when there is a radical.
Done. That's the last one.
All right.
Are we doing 6.2 today?
No.
We are.
Let's okay. Let's do one more radical.
Okay, yeah.
Do number 10.
Number 10, that's not
Which way do you want us to do it?
Do it as a radical.
Gotcha, coach.
Number 10.
I got like 6, radical 6.
What? 54, is that?
Yes. That's 9 square root of 18. Come on, get your
Teachers and students for this interruption. At this time, all other pep rally participants, including homecoming court members, and staff assistants, please head over towards the vandages. Thank you.
Well, I have the mic on my throat.
You gotta go.
Oh,
No.
looks like a cord does. That's what that
sound
is.
Guys, I got it. We got the answer.
That's what the sound is when
What? It's 9 squared. I was right. Or wrong. I got number 10 wrong. I don't understand how.
All right. Let's look at it. 18 square root of 18
Yeah, I got it.
times 54 is the geometric mean. So let's factor. We can do what's a perfect square that multiplies to be 18?
9 and 2.
9 times 2. What about 54? Is there a perfect 9 and 6? Good. All right. So we got 2 9s. We can bring the 2 9s out as a single number. So it's 9 times the square root of 2 times 6. Let's factor 6. What's 6 factors? 3 and 2. So it's 2 times 3. So now I can bring out a what?
That's 2.
Right, so it becomes 2 times 9, square root of 3, so that's going to equal to 18, radical 3.
No. I'm so confused. I don't. How did you?
Gotta get good.
How did you get 18 over 3? 18.
Okay, look here.
How did I get what, Justin?
The answer. I got 9 over 9 and 6.
9 and 6?
Yeah, I got 9, then I got 6.
Okay, so see this step we brought out the 9. We were left with 2 times 6. But 6 can be factored into 2 times 3.
Yeah.
I have 2 2s. So I bring the two 2s out as 1 2 on the outside.
Already a 2 in there, and then a 6.
And then you
Well, I was just trying to do it.
multiply the 2 times 9, and then 3 you can't factor 3 anymore. So it becomes radical 3.
This would just have. Because I had 2 times.